Alright, in Chapter 14, the first three-dimensional figure that we're going to study is a plane, which is really the building block of all three-dimensional figures. And a plane is a two-dimensional flat surface that extends forever. So the first thing that I want to do is get kind of pretty good at drawing a plane. To do that in two dimensions, it really looks like a parallelogram. So I'm just going to draw a parallelogram, and then after I finish this, the name of a plane your book uses a script letter, and that I can't really do that well. So I typically just use a upper English case or upper English letter, uppercase English letter, and then there's different things that we can really do to visualize this in three dimensions. So, for example, I could draw a line over the plane. Okay, so again, you have to use a little bit of visualization, but this line does actually not intersect the plane. I could make a line intersect a plane if I did something like this. So it hits the plane, say here, goes through, and then continues on the other side. Okay, but this red line does not touch the plane. That is over the plane a little ways. Okay, but the key idea is that three non-collinear points determine a line. So the reason we can't use two is, well, 2 points determine a line, right? So if I have 2 points, we learned before that they determine a line. Now, that isn't the case with a plane. So again, I guess this could be a plane, but it's not a unique plane, because I could have, now this requires again some visualization, but the plane could either go along in the direction of the line here, or the plane could actually be coming out at me, so going into the paper and out towards me. So again, it's not a unique plane. That is why I need those 3 points. Okay, if you remember as well, so if these three points are on the same plane, then I can enclose them in that plane like so. Now, if you remember, 3 points also determined a circle, okay? And so one thing that we really want to be careful with when we discuss planes for the first time is talking about intersections of planes with different objects. So my first question here is, what figure results from the intersection of two distinct planes? So if I attempt to draw this, I'm going to have one plane as kind of my flatter surface. Okay, and then the other plane I'm going to attempt to draw straight through it. And so this is going to look something like so. Okay, and again, this cuts down the middle of the plane. So it would look something like, if I drew a line here, it would be a dashed line here and then through it. For example, I could, again, a plane consists of infinitely many lines, so I can choose whatever line I want, but the idea is that if you look at the place where those two planes meet, the red and the blue plane, the intersection is actually a line. Okay. Second question is, what figure results from the intersection of a plane and a line? So if I start with a plane, and then possibly make a line with it. Now here we actually have several different cases, so let me move this just a little bit, and I'm going to make a few copies of this. Okay, so here's my plane in each case. I think there's going to be 3 cases. Okay, first thing is that the line could be not intersecting the plane. So it could be a line that looks like this above and what we would consider parallel to a line, some line on the plane. We could also have the line going above the plane, like I mentioned in the previous slide. So in this case, we would say that, and in particular in this case, we would say that the line is skew. So this is no intersection. And then in this next case, well, what if it hits in exactly one place? Kind of like I showed this case as well. So if I take a line and it hits the plane, goes through, it would look something like this. So this would just be a point. And the last case is, well, we might get lucky and the line might actually lie on the plane. Okay, so this is directly on the plane, and so we would actually say that the intersection of the line and a plane is actually the line of interest that we started with. Okay, now next case is, now we consider two lines that are not coplanar. Okay, must they lie on the same plane? So, coplanar means that they lie on the same plane, or must the lines intersect. So let's say that we have and so let's just try to visualize this a little bit. So if I have a line, okay, and then I make another line that is, so this would lie on one plane, one surface, and then this red line is above it some distance, so there's some vertical distance here. So this is really what it's saying. So two lines are not coplanar, that's the condition. Must the lines intersect? To me, I'd say no, because they're separated by this vertical distance h. So this is a case in which I have skew lines, so no. And then when are a line and a plane perpendicular? Okay, and then I want to consider the case when two planes are perpendicular. So I want to start with my basic plane. And then I want to know when a line and a plane are perpendicular. So here's the point of intersection, goes through, okay. And now what we do is we talk about a line on the plane. So this would be a line on the plane. Okay. And as with all perpendicular problems that we've studied before, we need to look at the angle between the line and the plane, if I call this theta, and that theta must be, the measure of that, of angle theta must be 90 degrees. Okay, that's a necessary condition for having perpendicular, a line perpendicular to a plane. Okay, and to do that, this is actually called a dihedral angle because we're in three-dimensional space. So that's a necessary condition. And then in the case of two planes, same idea. Okay, this one gets to be a little challenging to draw. Okay, so if I have a plane like this, I'm going to draw another plane that goes through it at sort of an angle. So here's that plane, and then it goes through and comes out the other side. Okay, and now again, here would be a line on the plane, and another line, and the other line that is on the plane. Okay, and again, yeah, this is getting a little hard to read, but again, I'm looking for this angle in here, theta, and again, that theta would need to be 90 degrees. Okay, same conditions as 2 dimensions, but now just drawing it and working with it in 3 dimensions.